Yeah, I started. Yeah, go ahead.
Let's start with first problem then. So our first problem is like a matrix is given and we have to sort them diagonally. So as you can see here, like in the what you say right top right corner, only single element one is there. After that one two, so it will be as it is. But when 3 1 2, that is sorted as 1 2 3, and again for the 3 2 1 as 1 2 3 1 2 and 1. And your constraints are like they have given rows m represents your rows and column, and then ij will be between 1 to 100. The elements of the matrix. Yep. So brute force one would be like you create a extra matrix, right? M cross n, and then you just start putting the elements in that way, right? Go through every
Okay.
diagonal. Yeah. Then
So pick a diagonal and sort it in some external data structure and put it back, either in a different matrix or in the same matrix if it's permissible, right?
yeah.
But will that not be almost the normal way of
And
doing it? Mhm.
and so, yeah.
Mhm.
Then
Yeah, I don't think so. There are any much tricks in this. It's more of a lot of implementations to be done, and some of the things we need to know about, like the diagonals, how
yeah.
they are, right? Yeah, and how do we handle them? That's the only key in this whole problem, right? Yeah,
Yeah.
because for sorting, either you will take the help of some external uh, algo, maybe like an external function, a library function of sorting, or use some other data structure. So either of
Right.
that should work, right? Yeah. Hmm. Okay. So what I found in this is more about how they have represented the diagonals here. That is the key, correct?
Yeah.
So yeah,
Difference of coordinates they are taking, and then
difference of coordinates in the sense.
I minus j they are taking and then putting it in a dictionary corresponding to that key.
Right, right, right. Yeah. So if you do an I minus j, so the way they, I think they started in most of the example is like you start from the zeroth row, okay, and then go for all the columns. So that will be your differences. You said like I minus j for all of them. And when you're done with that, so you stop on that zeroth row, then move to the next row. But in this, you just keep on incrementing the rows, but you do all of the diagonal collection on a column zero in that case.
Yeah.
Yeah. So either you do something like in this way, right? When you're done with that, then you go in this direction. That's the only difference, right?
Transpose. Yeah.
Yeah.
First you
So
zip row and then yeah.
so exactly the way he has represented here, you start with the zeroth row, zeroth column, and then go in the column direction. So in that, then you actually, when you're done with the zeroth row, zero column, zeroth row, first column, and so on and so forth till you reach the last column, and then you start moving in this direction, in the row direction, keeping the constant of the column at the zeroth column, right? And
Yeah.
then you sort them and then place them in the respective places.
Places and then yeah.
Yeah. I think this was a nice problem, right? To at least to understand how we'll
To
handle a case like this, right?
yeah. Or yeah, I thought BFS, but I'm not sure.
BFS, okay. How means? Yeah, there should be some
Like,
different ways also. Yeah.
no, I'm just thinking loud because we do this BFS in matrix, right? I thought let's pick this element. This will always be sorted only because single element, right? Now
Right.
you put these two into your array, sorry, queue,
Mm-hmm.
and you empty the queue
Mm-hmm.
and then place it back to the, in a sorted manner.
Mm-hmm.
No, but how will you sort it, right? You'll have to again store it somewhere and then or whichever is compare between these two, whichever is smaller value, put it first and then followed by this second, and so that when you will pop this one,
Mm-hmm.
that will
Okay.
come to your result, and pop till the entire elements at that level is finished. No,
Mm-hmm. Maybe take a level order in that case, but you still have to take in help of an external sorting mechanism, right?
for sorting you
Yeah.
have to.
Mm. So you, as you say, you go from the top right side first, pick that
Yeah.
element, and then whatever this its neighbors, they will be all left and right neighbors only, right? In this case, yeah,
But
all of them. Mhm.
how will you insert? Let's say you, you popped one, right? Now you'll insert once this and this. At that time, two will be in your queue only, right? Or you will pop everything at this level and then fresh insertion.
Yeah, so you will have to actually, when you're trying to form a next level of queue, you'll have to pop each element from that queue, the first queue, and place it in some vector or so. And so when
Place
you're
it,
done with popping everything, yeah, and then you form the complete queue, then you sort it,
sort it, yeah.
yeah, and then you place them back. Yeah, that might also
But
be
that's too
okay.
much of extra space. First you are using queue and then you are putting into list, sorting, and then doing right.
Hmm. Yeah, but it has a template to go, right? So it's like a BFS template. Yeah. Yeah, not bad. That might also work. Yeah, I think so.
That will take more memory, I guess. Right?
Uh, Commodore?
Sorry, Uday, could you be a bit louder? I couldn't hear you.
That if you're doing BFS, you need to keep track of visited as well, right?
No,
Really?
because level itself will tell you. I mean,
Mm,
whenever you finish one level, everything will be flushed out from the queue.
mm.
Next time, you will never visit this previous cell. I mean, previous level when
It is
you
a sort of a BFS. It won't be a exact BFS, but yeah, to some extent a modified BFS, right? I don't think so. Visited may be required in this case, right? We are actually jumping from one level to another.
another
No,
level.
But how will you get the next one? So let's take an example for the second row.
Hmm.
So second diagonal, it has 2 3, right? Or 1 2, right?
Hmm.
Yeah.
And now when you push the neighbor of 1, so the neighbor of 1 are 3 and 1.
Hmm.
So how will you determine that you already pushed one of
Okay,
them?
okay. Got your point. So, okay, in that case, you'll have to understand whether it's a duplicate and then it's visited or not. Yeah.
Exactly. Yeah, you
Okay.
should
Okay.
not. Yeah, in that way you need something.
Yeah. Okay. Got it. So for that corner case, you surely need it. Unless if we say, okay, if it's the very first element, I'm just going to pick up the only the right side and along with that the bottom. But for the next, I'm just going to take the bottom ones. Something like that. Either you do
No,
that way. Yeah,
even
maybe
without
maybe some trick like that. I don't know.
actually,
It won't be that so good. Sorry, what a pressure.
no, I'm saying even without using visited, you can mark the coordinate of this box and this box, right? Because
Yeah,
the
but
coordinate
you will need
of
some mechanism. That is what everyone is saying. It
Yeah.
won't be a very straightforward way to implement. Mm.
yeah,
Some tricks you'll have to do, but it will be possible. Yeah, I got. Yeah, good point, Uday, Praveen. Yeah, yeah.
it can.
So there are some additional things to be taken care. Yeah, go ahead, Praveen.
No, I mean I was
No,
saying like
Right. Yeah. Okay. So this was the one what we said, right? Okay. So the normal implementation, what actually we would think about, or maybe you have implemented one, right?
yeah, I have that one dictionary what you were talking like
Okay.
difference. Yeah. So I've taken one dictionary and calculating the rows and columns of the matrix and
Hmm.
just going through each element of them of the matrix, and whenever you find that this particular index is already in your dict, right? So you just append that element to the, I mean, corresponding to each, there will be key and a list of values will be there corresponding to the key. And if it's the first time, then you make first, what do you say, first, what do you say, slab or something like that, slot. And Now just you go through for every key in your, I mean, go through the every keys in your dictionary, and I mean this is a level, and sort them. And once you sorted, you just take the last element of that particular key value, right? I mean, sorry, first element of that every time.
Mm, okay, you are sorting it, and then when you are sorted, you have sorted that dictionary for a particular
Level
slot.
key,
Yeah,
yeah.
yeah,
And
then
while putting back matrix, you just pick the first element from every, what to say, key value corresponding to each key, whatever value you had in list.
okay, okay, yeah.
So matrix will be like this, like for 0 you'll have 3 2 1, right?
Mm-hmm.
And for -1 3, this for 2 and this and this. So now we'll sort it every this 1 2 3, it will become, it will again 1 2 3, it will be again 1 2 3. And now while filling the values, you just, because one will be at the front, so you take first element of each, I mean depending on the coordinates, you just start popping. So once you pop one, it will be removed. Now your list will be left with only 2 elements. So again next smaller will come on the front, that way.
Yeah, makes sense. Yeah. So you are using a dictionary or a map, and
Yeah,
your keys will be all that differences between I and J.
indices, yeah.
Yeah, and then you'll push everything and then sort them. So, yeah, that is, yeah, absolutely a good way of doing. Yeah. So this solution will be
It will n square.
in square, and then you are sorting also, right?
So overall it will be n square only.
Mm,
No.
okay. But for every
Okay.
whenever, mm, that's slightly
So for
you're.
whatever the length of your dictionary is, right?
Mhm.
So for every key you are sorting them. So length will be what? Four levels will, I mean, whatever the rows, not rows. One, two,
But at
three.
a time you are sorting just n elements at max, right?
Yeah, at a time only one. I mean, one.
N
That,
elements
yeah.
maximum. So n log n into n.
And log k, right? If k elements are there in one slot,
K log k. Yeah.
into
So
whatever the length of your dictionary is.
Yeah, so it will be an
yeah,
average
length of the
everywhere.
dictionary.
Yeah. Mm.
Yes. Amortized time, you have to take some.
Yeah, but you will have rows into columns multiplied by each other, and then the log factor, correct? It won't be n square, but n into m or something like that. Rows into column, and then the log factor for this
So,
sorting. Yeah.
no.
Yeah. So in this sorting, if you instead of using this sort, which takes n log n time, correct? So can we not use some different sort?
Bucket, you're saying?
Because if you look at the constraints, can you slightly scroll down in the constraints? See, they are saying your size is 100,
Okay.
and so it is not a very huge array, correct?
Yeah. At
So
max, it will come just of 4. Yeah.
yeah, so if you go diagonal, right? So we can have some array size of like 100, sort of array
The
of
mid,
100 size. Uh-huh.
yeah, mid diagonal.
In the mid diagonal, yeah,
Yeah.
and then take then actually do a counting sort, because the values are also in the range from 1 to 100.
Yeah, that should optimize more, right?
Yeah, so the sorting might be optimized over there, and yeah, so either that this solution sorting, or if you want to be, I'm not sure how much um, time complexity optimizations will get, but more or less it might be almost same, and not of a big difference. But in sorting, if we go this route, it will be most of the time and log n. So if counting sort, so counting sort will also have its own overheads, right? So you have this big array, and they keep on doing all this bookkeeping in it. So yeah, So that is one way of doing it. Use a counting sort.
And then, yeah, and then similarly you pop up the values right from each bucket.
It won't be a bucket, but it's like an array. You keep on putting all the elements based on its frequency. So if you have many duplicates in it, correct? So you'll just keep on incrementing the count, right? So at each and every location based on its value. And then when you come back, you again go through the whole array and then look for if there are values of whatever counts, and then you start putting them back in that matrix in the again diagonal fashion. But,
Yeah.
because if the array size is small, you still have a bigger size of array, right? Because you cannot say, okay, my array, my matrix size is like only of 10 by 10, and I will just form an array of like 10 or 15 or 20, because if you might have values more than that, right? Also, yeah, in that, so you'll always have to have that fixed amount of array. So therefore I'm saying there is some downside of it also, but yeah, one approach actually to think about. Yeah, or else you could
Yeah,
use
sure.
what else other than that, accounting sort, or what other way we can do this.
One we thought BFS, but not sure. I mean, implementation is not there. And
Yeah, that is one
other
approach.
is
Yeah, but other than that, maybe you can use a priority queue instead of doing Excel sort. You keep on pushing all the elements in the priority queue every time. The way you use dictionary, right?
what? So
That's
max
all
size
I'm
of
saying.
your what will be your size of priority queue? I mean,
Priority queue will be like for your diagonal only. Okay. So in
okay.
your diagonal, you keep on pushing all the values whenever you are going through that j minus one particular slot. You push all the values and then you start returning it back and filling it when you're at the end of that diagonal. So you stop pushing and then you start popping. So you'll have to use a min heap in that case.
Yeah. And at max the size will be of 100, right? If like 100 cross 100 is there, then the main diagonal,
Yeah, so
the entire
so priority queue size will depend on the diagonal size. Yeah.
diagonal size. Yeah.
Mhm. So it's not going to be like counting sort always 100, but it will vary
No,
based
only
on the
for the mid
diagonal.
one. Yeah.
Yeah.
Worst case, I'm saying.
Right, right, right. Yeah. I think these are the only few solutions what I saw.
It's not that the priority queue solution similar to what Shashank mentioned for the BFS. So instead of the sorting, you will use the priority queue for each level.
Right. But it will be almost similar to what he is doing here, like a dictionary, right? So instead of dictionary, you are using a priority queue. But dictionary, he is actually popping it out all at once and putting in a dictionary and then doing a sorting. So BFS will be slightly more overhead. That is what I was thinking.
One queue and
Because
one list.
you will have a queue and then another data structure, right? Yeah. Yeah, go ahead. Sorry. Shashank.
No, I'm saying one
It's
queue just
popping one by one, right?
yeah, I'm popping one by one. Like for that row, all the columns I'll pop one by one. And then go to the next row and again then pop one by one.
Even he can actually optimize this solution in terms of space.
Yeah, but you still need to have a queue, right? So, or maybe you have something else other than the queue, but something vector or so.
Yeah, either vector or queue, whatever you want.
Yeah.
Yeah.
So that will be an additional data structure. So yeah, they are all, these are all similar ones, but they have slight different variations. So what are some differences are that like BFS will have an additional data structure, and then priority queue will just have a priority queue. And in this case, he's using a dictionary, but he will have to have an external sort for that. Or instead of external sort, the normal sorting library functions, you use a counting sort. So yeah, so it can be solved in many ways. Yeah.
Counting sort and bucket sort is different, right?
Yeah, slight difference, but because counting sort, it depends on the values also, what you have. They can be of the same, in the same category too, right? Yeah.
If the frequency is one, then count sort becomes what is a bucket sort? I'm not sure. Like,
Right. So bucket sort has ranges, right?
yeah,
So if you have in a range, if you like a 2-digit, 3-digit number, a very high level or abstract level, if you think about it, yeah. So you can have different ranges also, like maybe 10 to 20 or 20 to 30 and all that. But here counting sort, you're just taking a single value. Okay. In this case, if you have 111, 222, 333, all of them, they will be put as a count, right? It's like a frequency count.
yeah,
Mm. Yeah. So I just went through the discussion. I saw these two, a couple of them. So thought of mentioning here. But as you said, this is the only main thing about it, right? So you go through this diagonal, okay, and then get this I minus j.
yeah,
Yeah, that is very important. And other than that, it's a normal way of implementing it. So whichever way you prefer, it works.
yeah. So, any approach, or shall we move to next?
Okay, yeah.
Um,
If you want, I can show you the counting sort, how it is. It's not very different than what you have done. Okay, so here you see, like, so the way you are going through all of these, all of the diagonal j minus I, right, in that case. So I'm actually going through the way, it's like go through a first row and then go for all the columns, okay, and then go for the remaining, okay, it should start from 1 year, right?
yeah,
Okay, and then go for all the rows with 0th column, and then do count sort for all. So when I'm doing count sort, I'm actually filling back the values also. So this is the count sort. Okay, it's like having this frequency array of 101 size, and then updating the frequency, okay, using this matrix values.
mm,
So once you're done, it's like just going through the whole frequency array again, and if it has some value in it, okay, then you keep on filling this matrix again based on what the value it is, right? So the very simpler.
count sort is helping to, reduce the normal sorting. Normal sorting had you used, it would have been n log n, right? That you are optimizing using count sort.
Yeah, you can say that. Yeah. So counting sort is the basic sorting algorithm, right? So you just count the number of elements. So that is what we do in the frequency.
Yeah, 101.
Yeah. It's very specific test case, right? It cannot be implemented. It's not a very generic one, right?
Yeah,
So it's very specific to the values when we have, and the values have to be in that range. Then only you can use a counting sort, right? So it
yeah.
has its very specific applications, and yeah.
So next we have to
So
predict.
Santosh, do you have the timing data? I mean, for the C++ solution based on counting sort, how it performs
Yeah.
on that?
Yeah, actually, I tried with all of these.
Oh, okay,
They are
okay.
almost coming the same. Yeah, I can quickly show. Uh, can you unshare it? Yeah. I didn't feel much of a difference. Therefore, I said like the way he has implemented also. See, like it's 20, 36, 28. All of them almost similar.
Okay.
Maybe here and there a difference. Because I did with counting sort, and then I use a priority queue also. Okay, so some of the values are for the priority queue. Yeah, so both of them. So that maybe the priority queue was giving me 32, 44, something like this, and then the counting sort is giving me few like 4 or 5 milliseconds here and there. Yeah, maybe a slight improvement, but not much.
Okay, thank you.
Either of should work. Yeah, thank you. Sorry, go ahead, Shashank.
Yeah. So next is like path in a zigzag labeled binary tree. So we are given an infinite binary tree where every two node will have two children, and the nodes are labeled in row order. And in the order, in odd one, it's like first, third, and fifth. The labeling is from left to right, and in even the second, fourth, and sixth, right to left. So we'll be given the label of a node in the tree, and we have to return the labels in the path from root of the tree to the node with that label. So for level 14, we can see 1, 3, 4, and 14 it will come, right? 4, yeah. 1, 3, 4, and 14, this path.
Yeah.
Yeah.
1, 3, 4, 14. Mhm.
And for 26, they haven't shown. Yeah.
So it will always be a full binary tree.
It has to
Yeah,
be,
they
yes.
mentioned every node, typical one, yeah, it has two
Has all
children.
two children.
Always.
Yeah. It is a full binary. Yeah. But you don't implement a tree, correct?
Yeah.
So here we have to just find the path, right?
Yeah, what all nodes are coming in that path, yeah. That's what they haven't given in signature also, I mean, regarding tree. The
Yeah.
function signature. Yeah.
It doesn't have a tree node.
Yeah.
Does it matter here that it should be full binary tree?
And that
You-
helps
Yeah, you imagine that is what they are saying.
because
Yeah.
then we can imagine this to be an array, right? Like
Yeah.
the left child is at 2 into I index, the right 2 into I plus 1.
2 I plus. Yeah.
But yeah,
okay.
reversal thing we have to take care of.
Mm. Yeah, but it's not very easy also, right?
Yeah, very.
The zigzag has made it it's like it's not so easy, more tricky and more cumbersome to implement. Because
But I,
if you do it your way, the way we think, right? Like if you use a min heap or so, the implementation, right?
yeah.
If you try to do that way, it's not that straightforward also.
Yeah.
So what does it mean here that infinite binary tree?
Because you can be
The
given
leaves are
any
not
node,
specified.
right? Yeah. So you can be given any number and then you have to traverse its path to the top root.
If it's infinite, then you have to bring the
Just
solution.
can I say?
Yeah.
Hello.
Yeah, go ahead.
Yeah. So I'm thinking like we can find the level for like if we want to find the level for 14, we can easily find the level, right? Or
Yeah, 14 by.
like through binary representation of 14.
Yeah, the closest 2 to the power of
Like
we'll
using
subtract and
binary.
yeah, go ahead, please.
So I'm saying like if we convert the 14 into binary and we will see like where is the last MSB. From there, we will find the level.
So
So next,
Yeah,
what you
I think what he's trying to say is that if I divide 14 by the closest power of 2, which is 8 here, right? So I know that it would be on the 4th level, right?
parent of okay, parent of
Yeah.
14, right?
Parent of 14. So at the first one, we have 1, at the second 2, then 4, then 8, right? So
Yeah.
that way, I think he's trying to divide by the MSP, what I got. What he said.
Yeah.
So just a second. I will send you one link. Just
If you want to annotate with that, okay, send the link.
like I have just sent the link. Can you open like?
Yeah, sure. Let me just for a second.
Okay.
Oh, that converter it is. Second. Yeah. This table, right?
Yeah. Yeah. Can you type 14 where like in enter decimal number just below this?
So,
Just keep it as
In the
second.
second, yeah.
Just yeah. Yeah. Convert. So I'm thinking like in the way like the maximum like the one will the leftmost one will be at the fourth position. So it means the 14 will be at fourth level.
okay, I think you are using that Fenwick tree concept, right? The LSB part you are taking this one and taking it to right. This is what we
No,
do
no,
in binary index tree. Yeah, go ahead.
so I'm taking the I'm not taking the like uh, I'm not taking the least significant bit. I'm finding the most significant bit. So the most significant is at if we started from zero side 1, 2, 3, and 4. For
This is
15 also
MSB.
it will yeah. This is the MSB. So I'm saying MSB is at fourth position. So it means that this number is at fourth level.
Yeah, that is the concept for binary index tree also. I mean, the one which you are saying.
Okay.
Yeah.
So like for the 15 also it will be the level it will be 4 also. If we go for 16 then level will change to 5. So I'm thinking in that level that way. So we will find that okay this is at fourth level. So we can see that the number end at third level. It at previous level is at assume the 2 raised to the 3 is 8, it will be at 7, right?
Hmm. 2 raised to the 3
From
minus.
7 we will see like uh, if we see in the, can you go to the diagram? Yeah, so if we see 14 if we start from 8, 9, 10, 11, so these are 4 nodes. 4, then 5, fifth one is 12, then 13 is 6th one, and the 14 is 7th one. And we if we divide 7 like 7 by 4, then we will get the count as 3. Or we can say that we will like we will increase the number 1 if it is odd number. So assume that it is at 7th position, right?
Okay.
So 7th, if we increase number 7 plus 1 is 8, 8 divided by 2 is 4. So if we start from 7, if we see for the 7th node, we will pick that node at the previous level. Then 14, 4. Similarly, we will see like 1, 2, 3, 4. 4 divided by 2 is 2. Then we will see what at previous level, what is the second node. So that will be 3, right?
So
And
Yeah,
in
yeah.
this way, 14, 4, 3, and 1, we will do this.
Yeah, he's trying to actually go via like find a parent of the current table,
node.
right?
Yeah.
Yeah. So 14 divided by 2 will be 7, but here it is actually swapped. So you'll take 4, correct?
Yeah.
So when you have 4, you actually divided by 2, you'll get 2. But here again it's swapped, so it'll go to 3, right? And then 3 divided by 1, and 2 will be again 1, so you'll go to the root. Yeah, makes sense. Yeah. Yeah, but the trick here is when you go to a next level, always it is swapped, you know. So when you divide
Swap.
14 by 2,
Okay.
correct, it's like completely inverted, right? So every alternate level is, if you look at the first level, the root, it's only 1. But if you go for, it should be 2 3, instead of 2 3 it is 3 2, right? But then 4 5 6 are like the way it is, 4 5 6 from left to right. Okay, but then you go for 8 9 10 11 12 13 14, they are from right to left.
Right to left, yeah.
Yeah, so that is what
Yeah,
I mean, the direction swap. Yeah,
yeah,
so
yeah.
that is the
Like
only thing you'll
if
have
we
to take
want
care
to
of.
yeah. Like if we want to solve it without swap, we can do that. Like we will not do the swapping. We will like solve for the simple problem where 1 2 3, and the next level start from here the 2 is started from the opposite position as compared to the 4, right? So we can solve the question if the 2 and 3 are swapped. I'm saying like 2 will be started from the opposite position.
Right side.
So like we can solve in that first, like yeah, like it will be on right, the 2 will be on right side, and similarly 8 will also be on right side. We will solve the problem for that scenario first, then we can like solve it for the next step also. Like
Oh,
yeah, like
okay.
if we want to go with the easy approach.
Oh, okay, yeah. So you're saying you go with 14. 14 divided by 2 will be 7. Then 7 divided by 2 will be whatever it is, 3.
3, yeah.
Yeah, 3 divided by 2. Yeah, absolutely. And then when you get all these values, you again go, and for the alternate ones, you try to match as per the left and right direction. Okay, right and left direction. Yeah, yeah, makes sense. Yeah,
Okay, so you start with 14 and then you go to 7, right?
yeah.
So after that you go to 3. So
Mhm.
how do you come to 4? You are going in the second traversal.
Yeah, when you go to
I didn't
second
understand.
traversal,
No.
okay,
No,
here's a different.
yeah,
Okay.
we can do in that way. I'm saying like we will not solve this problem. We will solve for the simple problem.
Okay,
Okay,
simple
can you
problem is
annotate
when
that?
they are not reversed. That's what the simple problem is, when they are not reversed.
Yeah. Like we will solve for the simple problem, then we have at least little bit like then we can complement it. Like if we are not able to solve the directly this problem, I'm just saying to solve it in easy way, little easy way.
No, actually,
Okay.
that is also good way. Yeah. In fact, it's more better also doing that way, right? It's
Optimal.
again only 2 pass. Yeah, it's optimized. Absolutely. Do you have something to share? Hello?
No. I am just like looking into this question 15 minutes ago. Like then I thought like I will say it like whenever this question will come.
Oh, okay. No, but that is a good approach, and it will pass the lead code time complexity. Yeah.
Yeah, it's login only because
So
he's
Santosh,
converting
I
binary.
didn't get how are we taking care of the reversal part? Can you explain that, or anyone?
Well, a reversal part, when you go to these alternate levels, right? So every time, so that is trick we'll have to use for everyone, right? So you'll have to find what is the difference between this. Okay.
Yeah.
So if I go first 14, then I will have 7, right? And then I will have
Mm-hmm.
3.
3
3.
1. So when I come to 7, okay, so I know that
Mm-hmm.
this one is from 4 to, oh, so
7.
7 is 4 to 7, right?
Yeah.
Yeah.
So then I will take a difference. Okay, this will be my difference. 7 minus 4 will be 3. And then depending on my mid, okay, wherever my this thing will lie, because I'll have to actually divide this value, right? So where this in this case it is at 3 7, right? So if you take the mid of this, 4 by 7 will be 11, and 11 by 2 will be 5.
5.
Yeah, so 5 minus 2 will be 7 minus 5 minus 7, 7 minus 5 will be 2. So in that case, so we actually 5 minus 7, so 5. Okay, so here there is a problem with this odd and even. Okay, so we'll have to be careful with the mid position. And then instead of going to the right side, we'll have to go to the left side that way, right? Yeah, that
So
is
it,
that is slightly critical, to get this when it is an odd value. So in this case, I would say you take 4 to 8, Okay, right? And then, or maybe,
Mhm.
yeah, it is 3 to 8 or 4 to 8. That is some value actually they are taking for the streak. And then you find 8 by 4 will be 12, then it will be 6, something like that. And then 6 minus 7 will be only 1. Oh no, yeah, I think 3 by 8 something. So you'll have to use that trick to actually
Yeah.
get that value. And so that is very critical, So I actually spent a lot of time in that, and it was not so easy to get up with. But you can do the swapping. If you do the mapping straight away also, just take your array, like if it is a simple array, 3, 4, 5, 6. Okay, 3, 4, 5, or 4, 5, 6, 7, right? So if you have like this array 4, 5, 6, 7, and then you are mapped at this one. So you know that you are at the very zeroth index, and you have to go start from the left. In that case, you just go to the left. Okay, either of it. So you just count where you are. So in this case, in second, if you are at sixth position, so you know that you are from one position from the right side. So in the left side also, when you're swapping, just go one position to the right. So you can do this calculations in O of 1. So that will be slightly easier to do, but you'll in this case you will actually spending more of the space complexity using an additional array or some data structure, but that will be slightly easier to do instead of doing all this math calculations. Yeah,
Okay. Yeah.
so there are slight different ways, but this case we'll have to handle for all.
Yeah.
Yeah,
Yeah. Yeah.
that's the only trick of the Zigzag. But this is a really
Mm.
beautiful problem, right?
Yeah.
But the way
Yeah.
they have solved is very different. They don't even go this route.
Yeah.
Yeah.
So I think if I'm able to find out like to which particular level my node belongs, then I can find out the extent also, the leftmost one and the rightmost one.
Hmm.
And using that, I have to find the mirror if it's a reversed one,
Yeah,
right?
mirror. Yeah. Mm-hmm.
In the left or right part,
Mm.
and then this would be a log of n as I mean log of not log of n O of height.
Yeah, it should be off-white. Yeah.
It is a balance only, so it will
Mm.
be
Yeah, log of n will be.
log of h or n. Yeah.
Could you explain, Harshit, what you are thinking here?
So I'm thinking, let's say I take this example of 12. Okay. So
Okay.
the way Hello was saying, he was somehow able to find out the level, right? So I was thinking of going by the GP way. So 12 is a number, right? So before this 12, I have my 11 nodes placed in my tree, some way or the other. So there's a pattern, right? On the first level, there would be one, and then two, then four, then eight. So
Mhm.
using that GP sum, I can find out to which level this 12 belongs. So 12 would be on this fourth level, right? Now uh, I have to go back. So this would be 12, the parent of 12 would be 5. But how do I get 5 here? So 12. Okay. So had this not been reversed, then the parent would be this 6, right?
Yeah, by 2. Mm.
Yeah. So because the parent node is I by 2.
Yeah.
Okay.
So 6. Now my job is to first check whether the level I'm currently on, which is this third level, 4, 5, 6, 7, that is reversed or not. So that can be, I mean, I have to check, like do the same thing for 6 now. And since this is at an odd level, then this is a reversed level. Now this is one thing. Now I have to find the mirror of 6. So for that I would need uh, like how many nodes are there in this level. So for that I would need so I know that this is the third level, right? So the third level starts from 4 and ends at 7, because the third level would have 4 nodes. So yeah, something on that lines. Then I can figure out the position of 6, which is third. So uh, I have to look for the mirror of 6 in the left part. So that would be the first node from the left. So 5. Yeah, I mean, it's easier said than done.
Yeah. But usually
Yeah.
what they do is, whatever level you are, like if you are at level 4, there itself you actually find the mid, the mirror label, whatever you can call, and for the next level. But you are at level 4, and when you want to find what it is going to be for your next level, like level 3, so you find at this level 4, and then divide by 2, because that odd and even length gives a lot of issues.
In one of the discussion, I was saying they are taking at every level the max and mean value. They add it. I mean, here at this level, your mean value is 8, max is 7, right? And you want to find for 14, and you subtract it. Whatever you get, divide by 2. That will give you the parent 4.
Right. So that is more
Yeah,
easier
that
to
makes
do.
sense.
Yeah,
Yeah.
that is more easier. So it's
But
almost like the mirror label you are finding.
so Shashank, why will you get 4? If you find the mid of 15 and 8, that would be 15 plus 8 by 2.
No,
That would
like
be 11, right?
this is 23. 23 minus 14 is 9, and 9 by 2 will be 4.
No, it should be 8 and 15. Correct.
Yeah.
Yeah.
So
So
I think what
23 minus 14. Yeah, 11.
I didn't get 11. How?
So 15 plus
so
8 will be 23, right?
23 minus 14 will be what? 9, right?
Oh yeah. Okay, 9. Yeah.
And 9 by 2 will give you 4.
4. Yeah.
but why 23 minus 14?
So he's taking the left
Okay.
and right.
Yeah, this is the mean
Okay.
value, this is the max value, and this is the current node for which you want to find the parent. Because for normal tree, what you do, n by 2 you do, right? For the normal parent. I mean, if a tree, like if you find the parent, but they have been reversed by that, what you say,
Yeah.
right to left, left to right. So whatever is the span of this length, that they are adding and then
Yeah.
subtracting this.
Correct.
I'll
So
show you. Yeah,
so
go
in
ahead.
order to find 4, which is at level 3, so he is
Yeah.
doing the calculations at level 4, okay, and directly getting the value of 4. Okay, so first do calculations at level 4 and just divide by 2, so you'll get the value which is required at level 3. He's
Yeah.
doing exactly that, right? See, 8 plus 15 minus 14, and then you divide by 2, and then you
Yeah.
immediately go to the level 3. So that's not very intuitive
Easy.
also, but yeah, but it works perfectly fine.
It's working.
Yeah.
Yeah,
Yeah.
like
Yeah.
simulation.
It looks very easy, and
So,
if you want to really go the way you think, it's very hard to implement. Means the way at least
yeah.
I was thinking about. Yeah. Mhm.
Yeah, that's
Yeah. So what he's doing is that he's imagining this 14 to be 8
Hmm.
or 9, right? 9, right? Because that he's making it a proper tree, and then going back would be easier. Because that is why you're doing 23 minus 14, right? That gives us the position.
Okay. You go to the 9. Yeah. Oh, if you look at that way, then it makes sense. Correct. Because you're swapping at this level itself.
Yeah.
Okay.
Yeah.
Whatever level you are. Okay. Then if you think that way, okay, yeah. Then it is slightly easier to follow, and yep, makes sense. A good one. Thank you. Yeah. Or else someone was using a float value to calculate this mid values and then convert back into integer. And so that actually plays some trick when you have all these odd even issues.
Yeah. Or this the hello what he was talking, the binary index tree approach, that will also work here. I mean, with some modification.
He was not talking about binary index. He was saying that you do it for all levels in the normal way. Correct.
Yeah.
So exactly, but he was saying you have a bit representation of 4 for a level for a number value 4. So you'll have 4 levels. That is what you're saying. So you'll have to do all these 4. Your answer will be of size 4 in that case. But then you do it the normal way, and then again come back and swap it for these odd levels.
Yeah.
So Shashank, how do you find the maximum and the minimum node for 14?
maximum will be your 8, right? I mean, you go through the level and you can use a level order traversal also and take two values.
Okay, are you simply saying that just one level down every time?
Yeah.
Mm.
Or let's see, I'm just thinking.
So in that case, you can see whatever you are at level. So if you are at level 4, right? So it will be 2 raised to level 4.
Oh,
Okay.
that max value. Yeah.
Yeah,
That's
yeah, but how do you find the level then? First of all.
Level you just find by log2. Use a log2
Okay,
function.
okay, okay.
so your max value will be 2 raised to power n minus 1, and your mean value will be
2 raised to n.
2 raised to n.
Yeah, 2 raised to n
raised to
minus
y-
1. Yeah. Mhm.
Yeah, 2 raised to
This-
n minus 1.
Something like that, yeah. And in case if you want to find the log2 usually will give you the
height, at which level?
yeah,
Sorry.
yeah. But if you want to find 4 bits, then you'll have to use a floor value of that log2, right?
Yeah.
So if you use a function floor and then use log2 inside that, then you'll get the maximum bits.
So floor base it will give you, right? If it's 4.2, then 4 it will give, right?
4.2.
Will be 4 for the floor, and seal will be 5.
Okay, ceiling will be the other way, right? Okay.
Yeah.
Mm.
So this is that code. I mean, this is my resultant array, like in which and node count is 1 initially and level is 1. Now, as long as my level is greater than 2 into node count, right? So we simply go to the node count will increase by 2 by every time, right? I mean, if it's 1, the next you'll have 1 into 2 nodes, then 2 into 2, 4 nodes, 4 into 2, 8 nodes.
Okay.
Yeah. And every time you increase the level also. And this is what you said. As long as your level is not 0, so you can find the max and min, as you said, 2 keep our level minus 1, and this one for the min one. And just what I told, max plus min minus current level, just divide by 2.
Yeah, this is clean.
Yeah, and reduce the level by 1 and just reverse your result. So it's again open, not log n, right?
Why often?
No, it's
This is
height of the tree. It's exactly the same what I just said.
no, but this one while reversing your answer.
It won't be this O of n, right? You are jumping nodes. You are taking only one node from one level.
Yeah.
In your final resultant array, you will just have one node from every level. So the stack size would be the height,
Height
which
of
you've
the
written
tree.
on line number 5. So I don't think it should be often.
Yeah, it's log n. Yeah,
Okay.
it is always log n. Other operations are just O of 1, right? Anything
Yeah,
what you do, yeah, there's nothing. But it's not easy to come up, or maybe
Yeah.
yeah.
This line number 17 is like very beautiful.
Yeah, now it makes sense with the way you said, like,
Yeah.
Arshad, if it's 14, you imagine that to be 9. Yeah, then you divide by 2.
Yeah, we are finding the index only.
Yeah.
Using this.
And this is the most cleanest way of implementing. Yeah. Yeah.
Yeah. Then
I will show you the float way, how it is. So you'll see how ugly it is. So this is the way one implementation was. You go through, find this level here, and this is your current label actually I'm assigning here, and then going through this current, and then you just push that in the first one, and then this is your start and end. For this will be for the next level, like 4 and 7, where you're going. Okay, and then you find this midpoint, and based on your midpoint, now you have to actually form this label, right? So always this mid will be a float value. Okay, and it makes sense to be a float. if I was trying to convert this into an integer value and do all that, it was messing everything. At least some corner case it was messing up. So if you do this float of this mid, okay, and then you take a difference, that also you have to take in a mid float. So then you actually take a difference with your current value and the mid, and then when you are done with this diff, again convert it to an integer, and then you find your mirror label, and then at the end you divide this by 2, so you get your current, and then you keep on decreasing the level
every time. Yeah.
yeah. So these things are also not so good, and you'll have to always be very careful about this.
No, yeah.
So this was one implementation.
Mid
So
mistake.
yeah, it's very difficult to follow. So, but the way Shashank implemented is the most easier way to even understand, right?
Yeah, if that formula hits.
Yeah. No, but if you see the way Harshit was saying, if you imagine that to be a 9 on the current level,
Yeah.
yeah, then it makes sense now.
Yeah, then it's like, I mean,
Hmm.
yeah, then we can move to next. So here this count and say. So it's a sequence of digits defined by this formula count and say one, and is the way you'd say the digit from count and say -1, which is converted into different digit string. So let's yeah, I mean, if number is given like this, you have to print in this one two threes, three twos, and one. The way we speak, right? 1 5 1 1.
Mhm.
So this should be bar. I mean, threes occurring. This prefix will give how many times the suffix is occurring or other ahead of it. Three twos, 1 5, and just concatenate and then return this 2 3 2. This one. So this is what happening here, right? For one, there is only one, so that's I mean, base case or best case. Coming to 4, so if it is 1, so 1 1 is there, so it will be. So they are not writing 1 1 for 1, right?
Yeah, the first one actually they just say 1.
Okay, yeah.
So
Then
actually the way they are showing in the example is very different, and then yeah, so
Yeah.
therefore it confuses.
yeah.
So the
So the
first one
first
is
number is
also
not okay.
Yeah, go ahead.
So the first number is not like, what do you say? The English
Yeah,
equivalent of
basic
that count is
yeah,
not taken, right?
considered, yeah.
maybe it's like a base case. Yeah,
Okay.
yeah,
At every
yeah.
and since and 1 1 count and say if you say 2, so 2 will be 1 already 1 you had one more 1, so 1 1. This is right. It's a
Mhm.
binary representation. What? Okay,
No,
is it?
no, let's not go. Yeah, it's not binary representation. It's exactly the way you are saying. Yeah. So that is what it says. Count and say 1.
Okay, two, okay, yeah.
Yeah.
It's they should have really reworded this question more like, oh yeah, given the first string is 1, second string is 1 1, third string is 2 1, what is the nth string or something like that.
Okay.
More like count first and then say the number. Yeah.
Yeah, that is interesting. Yeah.
Here I have one question, like if given number is equal to 4 input, so the output should be any, like only it is 1 2 1 1, or is there any number?
So basically what we're doing is to generate the nth term. So in your case, to generate the fourth term, we're counting and saying the n minus 1 term. So 4 minus 1 third term. So if you see third, so there's third, we have, string of 1 1. So we're basically saying count 2, that's a count, and 1, and that's our number, 2 1. So you see what I'm saying? So counting and saying the n minus 1 term. That's what we're doing in the pattern.
Okay. Okay.
Yeah. It's a very unique problem. I mean,
Yeah, it's I don't know.
Yeah, so that is right. So you're saying count and say of n minus 1, the previous level, right?
Right. Yeah.
And then you keep on building from bottom, the base case,
Yep.
and come up. Okay, makes sense now.
so dynamically, every time you'll form a number and say the count, right? On
Yes.
the
Yep. So
okay.
we'll form a number 1. We'll count 2, 3, so on. And I believe the constraint is not so high. It's only goes all the way until 30th. Yeah.
Oh, is it okay? Mention.
Yeah.
Yeah. To previous whatever you are getting previous value that you will store right for the next.
Exactly. So you the way I did was you basically go from number 1 and whatever you, so let's say if I'm going for number 4, right? So I go I produce the number for produce my string for number 1, number 2, number 3. I pass it in, and for number 4 I basically write the code like just like what I said. I'll count the whatever I had for number 3 and say it, and that's my output for number 4.
Mm-hmm.
Go through that.
Oh, let me share you. Give me a few seconds.
So this problem is also not easy, right? It looks
Yeah,
easy.
it doesn't. Yeah, I
No,
don't know why they put it under easy.
yeah, this is not easy.
Maybe it's easy for some.
Yeah,
Yeah.
might be. Yeah.
Mm.
That's,
So the way I did it was,
It's not very medium also. It's between easy and medium. Yeah. Mhm.
yeah.
so if we, let's go, so, so I start with number 1. We know number 1 is a string of just 1. And now what I do is I equals to, now I already have what's for number 1. Now I have to start from number 2. So I say I equals to 1, I is less than n, whatever they gave me as an input n, I plus plus. So I result string. This is where I actually get my n minus 1 string, right? And I pass it in. I helper method does all the appending and all that calculation. Whenever I get that number, I pass it into my result string and so on until I actually go to my nth term. On where on that case I have to go and count and say my n minus 1 term. That's why it's I is less than n, I plus plus. So on this helper method, all it does is, so at first count equals to 1, um, and it looks at the first char, it builds a string builder, does the first, so let's look at one example actually. So let's go for number 3, right? Actually, let's go for number 4, 1 2 1 1. So when we're at number 4, we already know what's number 3 is, right? Because we're just passing. So number 3, we know it's 2 1. So here string will go as 2 1, and count is 1. Initial char, the first char is 2, right? String builder, so we don't have to keep on concatenating. I equals to 1, I is less than, on this case, 2, right? I plus plus. If s the char at I, if the first char is not, if this char is not equal to initial char, on this case it's not, it'll append count dot append initial char. So it'll still append, the count is already 1, it'll append 1 2, it'll append these 2, and then now initial char becomes the new first char. So initial char becomes a number 2, and count, it resets the counts. It counts 1, otherwise count plus plus. It goes to another loop. So in this case, it's actually, let's see, I, on this case, initial, if hashtag char at 1, char at 2 is not equal to initial char. So in this case, 2 and 1 are is still not equal. So it appends the count is already 1, and then initial char, which is 1, it appends the 1 again, and it I is less than, let's see. Oh, no. What happens is it doesn't, it only goes to one loop, because I equals to 1, I is s that length. On our case, I is less than 2. So remember where we were right here, where it says I1, string builder is 1 and 2. It exits the loop, and string builder append, it it appends the count, which is 1, and append the initial char, which is also 1, and it gives us a string. So basically, to produce my result for number 4, I'm counting and saying number 3, right? The same thing. If someone were to give me number 6, I'll produce the result all the way up to 5, and I'll count and say this string, and so on and so on. And that's what this code is doing.
Yeah. So you're saying if you take for level 4, so your level 3, that is 221 will be your base, and that is on line 21. So your s dot length will have s will be 21,
Yes.
right? And then you are forming the SB. So you what the way you are forming SB will be 1211.
Exactly. Yeah.
Oh, yeah.
Yep.
Makes sense, because you go to the count and then you just look at what the count value is.
Mm-hmm.
In this case, for 2 1, the first one will always be 1. So
Right.
your
Right.
count will always be 1, and therefore you are appending the count and then the character. Yeah.
Yeah. And now, in terms of time complexity, I'm still trying to figure out. I mean, we're doing one loop here, and we're as soon as we get our string, we're doing another for loop over here. So I don't know, O(n)
It will.
square.
Yeah,
And
interesting.
I
How do
don't
we get a
think.
time complexity here? Okay. So it is like an exponential, right?
Yeah, that
Uh,
things.
if you go to the 10, the digits are so huge.
No, but that's n equal to 30 is there. Okay. So it will
Not
be very big.
exactly exponential, yeah, but something more.
Polynomial, yeah, kind of.
But
Like
not even
nature.
n square.
Yeah.
It has to be more than n square, I think. Yeah.
For sure.
Yeah.
I don't
Yeah.
know, because if you say n square and then you are at 10, it should be 100, but it's not that long.
Yeah. It's very interesting. Yeah. Yeah, but this is how I did it. I don't know how you guys did it, but yeah, this is how
Oh, this is
this is
good.
how
Yeah.
this makes sense to me, to be honest. Yeah.
Absolutely, yeah. Now,
Yeah.
the way you explained it, actually, it is more clear. Yeah, go ahead, Shashank. Yeah, sorry.
No, I'm saying they're saying O of n time complexity.
Okay. So how is that then?
I don't know. Let's see. It's let me share it.
Okay.
Yeah, it's a
Yeah,
C++.
because someone will surely ask a question that way, right?
Oh, this is a C++ code.
Mm-hmm.
So if I mean this is a base case, okay. So they are initializing your result with 1, right? String as a string, and going from 1 to n, running from starting to generate second string. So same, they are calculating the size. And then
Yes.
Yeah, go ahead.
Yeah, so even if you see the first level, the first for loop is running from 0 to n,
Yeah.
but
And
inside you have a for loop for the digits, right?
but that is a variant, right? Like initially it will be 1 length, then 2, 3. It won't be always n, right? Like 2, 1. So length was 2. Then 1 to 1. It was 4.
So I'm thinking, like, because it won't be n square, right? Because this inside for loop is not going to be always n,
Yeah.
right? It will be lesser than n. So therefore they are assuming it will be O of n, and it's not going to be towards n square also.
It will be greater than n and lesser than n square, right?
It will always be lesser than n, much
Why lesser?
lesser than n, because you are
But
always getting one input at a time, right?
okay, yeah, from here.
That is what I'm thinking. Therefore they are assuming, okay, maybe it is like a O of n in that case. No, but it's not a straightforward way of getting that, right? Yeah.
I just saw that.
Yeah, this is good what you came up with. Maybe you need to do more reading on it.
I think runtime is at least of n square.
Yes, yeah, some of them are saying n square. Okay, that's good then. So we are not the only ones. Okay.
Length of each sequence is guaranteed to increase. Yeah, that's true.
Yeah, maybe we can have a discussion with the interviewer, right? In this case, like that, so we can always show the way we are thinking, and both of us to together agree on something. Maybe k of n, the way he is saying here, or
Yeah.
maybe n square. Yeah. So we have our own justifications. Yeah.
Yeah.
That should be reasonable. Yeah. Yeah, that was a good one. Hope we don't have any more questions, right?